Hey, before we jump into today's episode, we've got something coming up that we're really excited about.
Yeah, on July 22nd from noon to 1 p.m. Central, we're teaming up with Number Club for a free live webinar.
And we're going to dig into how math play can give you meaningful insight into your students' thinking.
If you've ever wondered how to support students who need more experience while still challenging students who are ready for more, you're definitely going to want to join us.
Plus, you'll get to see some of the powerful ways that Number Club helps build students' mathematical reasoning through problem solving and sense making.
Registration's free, and we would love to see you there.
Head on over to mathisfigureoutable.com/numberclub to save your spot.
That's mathisfigureoutable.com/numberclub. We'll see you on July 22nd. Hey, fellow mathers. Welcome to this podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
Y'all, we know that algorithms are super cool historic achievements, but they are terrible teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
Y'all, thanks for joining us to make math more figure-outable. Kimberly.
Hello, Pamela. How are you?
My life is full of wonderful things, and I'm always ready for new opportunities. Why are you laughing?
Because I know what that means.
Do you think that means I'm feeling a little full today?
My life is You're full. Your brain is full.
You know, I took a week off and we went, have we said this on the podcast?
I don't think so.
I recorded the audiobook for Developing Mathematical Reasoning.
Yeah.
Avoiding the Trap of Algorithms K-12. Super, super fun to do that. I took a few days off, 2 weeks off. So it really wasn't off, right? Because I was recording the audiobook the whole time. Why was I, what? Oh, because yes. Then when I got back, I had 2 weeks worth of meetings to catch up on. So I've been in meetings upon meetings about, it's just like the kind where you don't get a breath, and then like a dork, I just schedule them. So one ends on the hour and one begins on the hour. That's never so
5 minute window.
Need at least a 5 minute window. Okay. Note to self. Come on. 5 minute window. All right, Kim, today I am kind of excited this is going to be a little bit of a, what's a good word? Beat out conversation. Not in a bad way.
Are we going to wrestle?
Well, we're for sure going to grapple. Like grapple, wrestle. Like, I'm really intrigued with language and communication and actually understanding what each other means. And golly, you and I have known each other for a long time. So it's always fascinating to me when you go, wait, what? And then we kind of get under a word and we're like, oh, that's actually not, I didn't think that part of it.
Yeah.
So I've been in some situations lately where a meaning has come up. And so y'all, when you listen to this episode today, be aware that it's not like we're trying to force my definition on you or Kim's definition on you. We're trying to talk about a concept, a thing, like an idea, and put some words to it so that we all kind of get more clarity around it, so that when we can talk about it in math education and math teaching and working with kids and working with teachers, that we can communicate. So it's not about who's right or wrong or who's using the best word or anything like that. It's about, let's communicate. Is that a fair way to start this?
I think so. Yeah. Because if you're hearing somebody say something or you're listening to a talk and you think you know what they mean, but they actually mean something different, that not only could be confusing, but it could change the course of how you hear the rest of the information that they're sharing.
Totally. Yes. Yeah. Yes. Okay, so I thought I'd start with just a brief experience that happened quite a while ago. I was doing some training in Texas for leaders around the state of Texas. It was a wonderful opportunity I had. I had just written Building Powerful Numeracy for middle and high school students, and I did 8 days, not all together, but I had a group of leaders around the state that I got for, I think 4 days in a row, and then maybe 2 and 2, or maybe it was 2, I don't remember, it was a while ago. And we were building powerful numeracy. So I was literally doing addition and subtraction, multiplication, division problem strings with leaders so that then they could turn around and they could work with their teachers to build powerful numeracy, blah, blah, blah. In that, I was doing a subtraction problem string for the over strategy. So like I was giving problems and I was having people share strategies so that they would think about a problem like, I don't know, something random like 63 minus 49. They might go, well, I know what 63 minus 50 is. A little too much, go a little over. And if I know if I know that 63 minus 50 is 13, then I can think about only backing up, not 50, but only backing up 49. Just don't go as far. So you kind of have to, if I've jumped back 50, but I'm only supposed to jump back 49, I can jump up one. And so really the answer would be 14. So I'm looking for that. I give the problem 63 minus 49. And this gal raises her hand. She goes, I'm just kind of weird, but I just see sevens. And I look at the problem and I like, there's not a 7 in that problem, sweet participant. And she's like, it's just like I see 9 sevens and 7 sevens. And I I put my hand up. I was like, what? 9 sevens minus 7 sevens. So it's just 2 sevens. And I know 2 sevens is 14. So the answer is 14. Kim, in that moment, I was like, oh, that is clever. That is really clever. Ooh, kind of the ooh factor where I was like, is that a thing? Can you like factor? Now I know we've done this strategy on the podcast before. If you haven't heard of it, go check out the factor to subtract or factor to add problem strings that we've done on the podcast. But in that moment, I remember just having this, ooh, that is really clever.
Yeah. Do you think that it was clever to you at that time because it was something you hadn't seen before?
Something I didn't do. I didn't play with. I didn't own those relationships.
Yeah, because I don't know where you were at the time, like
I had
in your development.
I had never thought about factoring numbers to subtract ever.
Yeah.
And in that moment, so, I had to ask myself, is that generalizable? Like, is that just one problem? It'll never happen again.
Yeah.
Now I write whole problem strings with it.
Yeah. So you said it was clever, but what you didn't say was interesting. So you might have also thought it was interesting, but the word you just used is that you thought it was clever. So do you think that you thought it was clever because it was new to you, or that the strategy itself is clever?
I think that's
like even now as you've seen it and written strings.
I think it's a really good question. I think the strategy's clever. Now we need to define clever, and this whole episode is going to be kind of like what clever, a little bit about that, but because I want to kind of pull out what you think and what other people think. Yeah, it definitely was new. It definitely was new, and there are times where things are new. I'd like to talk about what makes it clever, even if it isn't new.
Okay.
Is that
okay?
I felt like you were going to ask something. Go ahead.
Well, before we define clever, can I tell you one thing that I'm thinking about right now? Please. Because maybe we should define clever first. So tell me if we should. But listen, we have been in situations, and we've even, when I was brand new to working with numeracy, I would say things like, solve this problem however you want, and then when you solve it, I'd like for you to solve it a second way. Mm-hmm. Or maybe like the piece of the directions on the assignment would say, solve the problem in 2 different ways.
I remember papers that had 2 columns. Solution 1, solution 2. Mm-hmm.
Yeah. Mm-hmm. Yeah. So the word clever has come up in lots of situations with you and I before, because we have said things like, we want people to seek for clever, and sometimes that happens when you've solved a problem the way that you are naturally the way that you
are kind of inclined
first are. Mm-hmm. The first way you think about it, and then you can like sit back, and then you can tinker, kind of the way we did in the problem string last week. Yeah. Like I did what felt like my first inclination, but then we kind of sat back a little bit and I looked for even more
other relationships that could come into play. And when you do that, you're kind of curious. I wonder if I can find one that feels clever.
Right. So what I think there's a difference here between solve every problem 2 ways and solve it however you want, but maybe then look for something also clever. So let's define clever, but I want to come back to this idea of solving things in a couple of ways, because I think there are people who are suggesting that and asking for that, because we want kids to have lots of strategies,
flexibility,
but maybe
right?
It's not getting them the results that they want.
Yeah. So one of the standards lists that we want kids to be fluent, and part of the definition of fluency is that we want them to be flexible problem solvers. And so
Mhm.
I think there is an idea permeating around that flexibility means thou shalt solve the problem in more than one way.
Yeah.
And so then it becomes a directive, of forced. And what we've seen is that when you force, in order to get a grade, I'm going to mark it wrong if you get a correct answer, but you only did it one way. Then we get all these hmm, misunderstandings, misconceptions, miscommunications, really, where a parent might say, "You can't mark this wrong. The kid got the answer right," and the teacher then kind of has to say, "Yeah, but they have to solve it in two ways." And the parent's like, "Why?" Like they got the answer,
Yeah.
and
Then it just
yeah, and sorry, did you want to say something?
well, I was just say at that point, it's just performative. It's
Yeah,
you did it one way, now do for me another
yeah,
way.
it doesn't feel very natural or helpful or desirable. It's just like you're doing it just to do it. And
Right.
then we find that when we're in that sort of performative, commanded, I have to solve it two different ways to get a grade, especially, then we find kids will solve it the best way they can because we're all lazy. So we do the best thing that we can think of. And then often kids will do something less sophisticated, less clever, less like they'll draw pictures that are super
600 tally marks plus
yeah.
300 tally marks.
Yeah,
Yeah,
there
yeah,
was a
yeah, yeah,
video that
yeah.
went viral shortly after the Common Core came out where the parent held up the paper and it had a ton of circles. It was the problem was something like 600 divided by 7 or whatever. And there were 600 or 7 circles and then 600 tally marks and it
Yeah,
all divided
yeah.
out. And it could be as a result of a well-intentioned sort of instruction to say you have to solve it more than one way, where a kid's like, okay, well,
Yeah.
I've seen this way, I'll do that. That same thing can happen when we say you have to show your work. If the kid's never seen their thinking represented, actually their thinking, what they're really thinking about, and you say, can't use an algorithm, you got to show your thinking. And the kid's like, I don't know how to show what's
Right,
happening in my head. Then they very
right.
often revert to something they've seen, which it could be a less sophisticated counting one by one, not what the whole thing when we're trying to mentor people to math, we don't want to force them to do less sophisticated math, right? Just to get a grade or get the nod or get the okay. We want to actually be encouraging them to reason. I don't know. Do you want to add on
Yeah.
any of that? Is that
Well, when you said they'll revert to something less sophisticated, if I've got a third grade student first 6 weeks of school and I tell them to show me their thinking, but we're tinkering with something new, when I say model your thinking, they're probably going to be thinking about what they saw modeled a bunch of times in second grade
mm-hmm.
because that's what they've had the most experience with. So it's kind of this delicate balance where we want students to be able to represent and talk about their thinking, but
Absolutely.
it's this very delicate balance of we need to give them the tools to be able to do that and the experience, under a careful eye of an educator who can
Pull
be
out.
there just in the moment.
Yeah,
Right.
pull out their thinking, represent it for them. When
Yeah.
your brain does that, it can look like this. And they get that experience. I love that you said experience. So they're like, oh, when my brain does this, it could look like that. Now then we start to say, hey, that your brain's doing that thing. Can you represent it? Can you show me what it's doing? Because you could tell me
Yeah.
right now. I love you used to say this. I quote you right now. You used to say, you could tell me right now, but this paper, I'm taking that home. I'm grading that at home. You won't be there to tell me. So what could you put on the
Hmm.
paper so I know what you're thinking? It's a
Yeah.
great it's a great way of sort of honestly helping kids realize that what we put on paper can be about communication. It can be,
Yeah.
how can I understand what you are thinking about when you're not here to tell me or draw, talk it out loud.
Yeah. Well, and I think we're kind of getting off topic, but this is fun anyway. But in that moment, then when I take that paper home and I look and see what they
hmm
put, and I know that kid, then I go, oh, they're putting something that looks like this, and I need to help them put what actually is happening in their mind. I've talked to them enough. I know the way that they're thinking
Nice.
about relationships, and I know that this is not necessarily representing their thinking. I mean, we have this beautiful picture of my Luke when he was like 5,
hmm
has all this piece of paper from first grade, I think it was. Sarah Hempel,
Yep.
amazing. She took Luke's paper, which had all these drawings,
One by
and
one.
she was like, "Hello, sir. I know that that's not what you're thinking about." And she represented for him and helped him see what he could do because she knew he wasn't,
Drawing.
drawing and counting
He
by
wasn't
ones. Yeah.
drawing the 14 squirrels and the 6 squirrels that were running down the tree
Yeah.
and
Yeah.
crossing them out, whatever. He did that after he'd figured out the answer because he didn't know another way to represent the fact that
Yeah.
he was thinking about 8 plus 6 to help him think about 14 minus 6. Yeah.
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 Nice. Something like that. I don't know this
Okay.
exactly the
Let's
numbers. I think this all
let's
points
define
to, well,
clever.
this points to
Yeah.
why you and I are encouraging teachers to help students seek for clever
Yeah.
solutions, clever strategies, clever ways of thinking, clever ways of using
Yeah.
relationships. But what do we mean by clever? So I could have this wrong. I'm going to say up front, I've traveled a little. I have some friends in different countries. So this is totally my take. And then we looked it up on the internet and the internet disagreed with me. So we'll give you both takes. When I use clever, I use it different than the way I read it in Harry Potter. So when I've spoken to a couple British people, it felt like British people were saying a person is clever. They're smart, they're brilliant, they're intelligent. I don't use it when I say seek for clever, that's not go find the smart kid in your room. That's not what we mean. We mean encourage to be on to try to find what innovative, elegant, creative, slick strategies. It's
Mhm.
less of a definition of who you are, like you're clever, you're not clever. Like Kim, would you call me clever?
I feel like it's a trick question, Pam, because I would say that you have clever ideas and I think that you look for clever strategies, but we're talking about here that people it's interesting because we're going to talk about how people have behaviors and we're talking about there's a behavior of seeking for clever.
Yeah, like
Yeah, I
trying
don't know.
trying
I
to have
don't
ingenuity, trying to adapt, trying to
Yeah.
be resourceful. Ooh, I just was talking to Canadians. Resourceful? That's funny.
Uh-huh.
Um, I think flexible fits in there.
Yeah.
Earlier when I was talking about the really cool factor to subtract strategy, and I thought it was clever, and I was like, ooh, it's kind of that ooh factor. Like one of
Mhm.
the things that we seek for, we're doing a problem string, we're working with kids. I'm even just chatting with a kid and they say something and I'm like, well, what about? Or, I just like, does that apply here? I'm seeking for a kid to go, ooh, that's, or a kid to say something and the rest of the class to go, nice. Ooh,
Yeah.
when they
Yeah.
do that, that kind of describes this thing that we're calling clever.
Yeah. I think it's important that you said what you just said right now that there is a kid who might say something and the rest of the kids go, ooh, because everyone in the class can provide that opportunity for the rest of the kids to say, ooh.
Mm,
Like there are
nice.
plenty of times where I do something that I go, oh, that was clever. And there are plenty of times where I go, that was not very slick. Like
Like you
there
trudge through a problem, you do the
oh
best
my
you can, and you
heavens.
look back at it and you're like,
Yes.
wow. Oh, especially then, if when you look back, you
Yeah.
go, oh man, I could have just,
Uh-huh.
yeah, yeah.
Uh-huh. Yeah.
Then that feels clever in that moment. Like you like when you
Mhm.
see the connection that you're like, oh wow, look at that. That's or in the midst of it, you're like, oh, ooh, and you want to share that. Ooh, it's that ooh moment. That's the innovative. I'm gonna say some words again: elegant, slick, creative, the ooh factor, ingenuity,
Mhm.
adapting, using relationships, connections, being resourceful, flexible.
Mhm.
Those are the things that we're sort of hoping for. We don't want to kind of wreck when we just go, okay, you have to solve it two different ways. You have to. You're not going to get a grade if
Yeah.
you don't. Yeah.
Yeah, and so in classrooms where if we talk about this idea of there being a reason to seek for clever, if there's a reason to take a second look at your work, if there's now that you've you just said that if I have trudged through problems before, I
Hmm.
have absolutely, and then I take a breath, I pause, I look back again because there is still learning to happen. There is still a reason for me to look back and go, okay, I have made it through one pathway. What now could I think about? And maybe there's not something in that moment, or maybe there's not at all. But often I have found that I look back and I go, oh, that would have been more clever. That would have been slicker. That would have been, more flexible. But I didn't see it in that
And we're
moment.
seeking to build, the habit of mind you just described.
Yes.
We're
Yes.
seeking to build that in ourselves and in our students. Now, you might be thinking, really, when you're like on a test, you want them to look. I mean, maybe, the only way I learned to check answers on a test was to undo or, like do the other operation or whatever. But instead, I could look for other relationships to use. Mathing includes the mindset that Kim just described of
Yeah. I
solving
mean, I think
problems.
life
Well,
I think life
one would
does. I
hope.
mean, I think there are plenty of things I do the hard way and then go, "Oh, that okay. Noted for next
Noted.
time." I mean, I think that's a mathematical behavior, but it is also a life skill that we're building in students to say, "This is not the one and only way. Can I look back and what next could I do the next time?"
And math,
And that's
keep going.
go ahead. I was gonna say that's drastically different than the always two ways. Every time on every assignment, always solve it two ways to show flexibility. I would much rather have students give it their best go and then instill this behavior in them and then sometimes they share with me something that they've come up with that they thought would be more clever the next
Yeah,
time.
this sort of mindset that mathing is looking for relationships and looking for connections and trying to seek for clever. And that's only possible, I think, when math is figure outable. Like if you're
Yeah.
approaching math as rote memorizable, then you're like, I have to solve this in two ways. God, I have to memorize twice as much as I did before. Like that,
Mhm.
that's not the perspective. And so I think part of the reason we wanted to talk about clever here today was just to kind of infuse just one more angle of what it means for math to be figure outable. And I think it
Yeah.
might be helpful to maybe just have an example. Kim,
Oh, oh, good.
yeah,
Yes,
okay.
because I grabbed an example that
Nice.
you shared the factor to subtract. One of the fun things about Math Strat chats on every social media on Wednesday evenings, and
Hmm.
there are problems that you put out that really get people excited. And often multiplication ones are really people chat a ton. There's we put out a problem 48 times 52 one time, and this is a strategy that I think is incredibly clever. And again, for me, it's not because I didn't own it before or that it was new. Although I did have that same reaction that you had in your story at the beginning. I went, "What? You can do that?" But I think it's a clever idea. For 48 times 52, people will sometimes think about the difference of squares. And so they'll think about 50 minus 2 times 50 plus 2. And so that for me is a really clever idea that you would think about a multiplication problem as difference of squares. And it's pretty slick.
It's
It's
nice.
pretty slick, pretty inventive. Definitely people are thinking flexibly because they look at it and they go, oh, okay, how far apart are those numbers?
Yeah.
Um, it's one that I want to do a better job of seeking for. And so when
Having it
people
occur
do
to
it, I
you.
go, ah,
Yeah,
yeah,
you want it to occur to you. When I see, I want my brain to do that next time. I want my brain to have that inclination, that spark to, ooh, I wonder if I could look for difference of squares. Just to be clear, so that 48 times 52, you said 50 minus 2 times the quantity 50 plus 2. So 50
yeah,
times 50, that would be 2,500. And then
uh-huh,
the minus 2 times 50 and the plus 2 times 50 add to 0. So then you have
yep,
minus 2 times minus 2 is minus 4. So really you end up
uh-huh,
with 2,500 minus 4. Bam!
right,
And you've got
right,
48 times 52. That's pretty clever.
yeah,
In a
it is.
way, both of the examples we used, I don't think that I want to parse out that I'm gonna name a commonality between the two problems that we used as examples, and then suggest that you're clever doesn't have to include that commonality. One
Okay,
of the commonalities in our two examples is that you kind of use something you learn later to solve something you learned earlier. So like I
uh-huh,
was solving a subtraction problem using multiplication facts, like factoring. Usually you
mhm,
subtract before factor multiplication facts by thinking about 9 sevens minus 7 sevens. You were solving a multiplication problem using something we usually do in algebra where we have a binomial times a binomial and we like do we distribute all the multiplication all the way out, and then we get a trinomial. These two examples we used have that properties and that description that they fit, that you're using something you learn later to solve an earlier problem in a very clever way.
mhm,
I think you don't have to do that to be clever. I think there are
right,
lots of other ways to use relationships and connections that just seem to kind of, I don't know, be the straightest journey between 2 points, and you don't have to do all the extraneous. I mean, a
Yeah.
very simple example would be 1,000 minus 998. If the only thing you've ever learned is an algorithm, when you learn that subtraction can be the difference between numbers, and you're like, well, how far apart are 998 and 1,000? You're like, whoa. Again, not because it's
Yeah.
new, but because you don't have to trudge through all those steps. You can just reason using a connection that
Yeah.
that's yeah,
Yeah.
nice.
Agreed.
Cool. So, always two ways, Kim?
No, not always two ways. I mean, if that's a goal you want to set for yourself,
Oh,
absolutely.
that's a nice
Be on
distinction.
the
That's a
hunt
nice
for
distinction.
thinking about a ways to solve a problem, because it's only going to help you to, like, build. If I see a multiplication problem, then I want to say to myself, is this a good one for difference of squares? But if I am assigning students work, I am not asking them to solve it two ways every time for a grade.
And you're not grading it if they don't. Like, that's not
Right.
part of the grade. Nice.
Yeah. Yep.
All right, y'all. Let's all seek for clever strategies. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.
Before you go, don't forget that our free webinar with Number Club is on July 22nd from 12 to 1 p.m. Central.
We're going to be talking about how math play can give you meaningful insight into your students' thinking and sharing ideas you can put to work right away.
If that sounds interesting to you, make sure that you're registered.
Just head to mathisfigureoutable.com/numberclub to reserve your spot.
We'd love to have you join us live.
We'll see you there.